Welcome to Help Your Math. Here we have a linear equation. If you notice in this linear equation, we have multiple x's on one side, multiple constants on one side. We have parentheses. So before we even start to isolate our x, we need to get rid of these parentheses. So that way we can combine like terms and we can eventually isolate that x. So we always want to get rid of parentheses first. To do that, it's distribution. This really doesn't change from one problem to the next. So let's distribute here. We can do both distributions at once, but if you're not so comfortable, you can do it one at a time. It's completely up to you. So on the left, we can distribute the -6. On the right, we can distribute the 3. And just be careful here. Remember the negative. It can be helpful to actually circle what you're distributing because a common problem is to forget this negative. Okay. So when we distribute the negative on the left, we get -42x minus 12. And when we distribute the 3 on the right, we get -12 plus 6x plus 3x. Okay, so we got rid of the parentheses. We still have the problem on the right where we have multiple x's. So we want to combine like terms. Remember that you're on the same side, so you're not using inverse operations here, okay? On the right, we have a 6x plus a 3x. You are adding them. So we get -42x minus 12 is equal to -12 plus 9x. So you're combining like terms. Now we can isolate the x. How do we know when we're ready to isolate x? We don't have more than one x on any given side of the equation. And we don't have more than one constant on any given side of the equation. So if we look at the left, we have one x and one constant. If we look at the right, we have one x and one constant. That's how we know that we're ready to solve for x. So how do we do this? We isolate. You can either look at the constant first to get the constants on one side, or you could look at the variables. I like to do the variables first. The reason why I like to do the variables first is just because I like to keep my x's positive. It does not matter. So again, you can do this in many different ways. I like to keep my x positive, so I'm going to add 42x to both sides. Adding the 42x means that it disappears on the left. And the reason why I do it first is because then I know that by making the variable disappear on the left, I'm going to move my constant to the left. So -42x plus 42x is 0. That's why it disappears. So on the left, we're just left with -12. And on the right, we have -12 plus 51x. So now we need to get the constant over to the left because we can't have a constant and a variable on the right. So inverse operations, we have a -12. So to get rid of it, we're going to add 12. Adding 12 to both sides. And actually, this is rare, but it does happen. -12 plus 12 is 0. So we just get a 0 on the left here. That's okay. So 0, the -12 plus 12 is also 0. 0 is equal to 51x. Okay, we still have to isolate the x, so we still need to get rid of the 51. We're using inverse operations, so we multiplied x by 51 to get rid of it. We divide. The 51 over 51 just becomes a 1. Anything times 1 is itself, so we just get an x. And 0 divided by anything is just 0. So our final answer here is x equals 0. And that is okay.